Hello everyone. Thank you for attending and having me here on the stage. My name is Andrey, and today I'd like to share with you a story of a tool, which idea was born on the last year's ElixirConfEU. So a bit of Elixir today. Few words about me. I used to be a .NET developer and had been written C# code for a while. Then I switched to Ruby, and eventually I work with Elixir on a daily basis since 2016. I try to contribute back to Elixir community with my open source projects. I write some articles on Medium occasionally. Currently I work at Karen Gaming Group based in Tallinn, Estonia. So it's going to be a story about the inspiration, a story of an idea which was born on a conference and went through implementation and some obstacles, and how actually it ended up with a result which actually everyone can try it now. Here is the broad agenda of the talk. I'm going to shortly introduce you my another library, Exop, just in order to make you a bit familiar with the problem which I try to solve. Then a few words about inspiring Andrea Leopardi talk on the last year's ElixirConfEU, then about the idea that popped up in my mind during his talk, and finally how this idea turned into some product. What is Exop? Exop is a library that allows you to define so-called operation module that encapsulates some business logic and validates incoming parameters to this module for this logic with public predefined contract. What does it mean? Here we see encapsulation statement. We have integers division module. It's an operation, and business logic is encapsulated in a process function, which takes a single parameter, which actually a map of parameters which were declared in a contract. And the keys of this map are names of those parameters. This is how the contract looks like. We have defined two parameters, A and B. They are integers and they have some checks. And once those parameters pass their validation, those parameters goes to process function. And once you invoke this process function, invoke actually this business logic, you are sure that incoming parameters were already validated and you can work with them. This is very simple example of contract for the sake of example, but validations may have quite complex checks, like here parameter items, which actually are list with minimum length of 1, and we specify that each list item should conform, should be a map, and this map should have three keys, three required keys: name, price, quantity, and each of these keys values in the map, they have their dedicated checks. So, and this nesting can be very complex, but I do not encourage you to define very complex nesting. Another good part of Exop is unified output, as we have already saw it in OTP 22. No matter what's went, we always know that the result of the operation invocation is either OK or error tuple. There is another version of run function which actually start the validation and then invoke the process function within operation module, we have a bank version of this function. It simply, in successful case, returns unwrapped result. In error case, it throws an error. And this like unified output actually allows you to combine a few operations much easier, and let's say within a with statement, for example. And I have invested some time to make error messages as helpful as possible. For example, even here we have a parameter A, which is a map with inner checks. We can get an error, actually the actual place where something went wrong. So here is the example of the operation. Okay, we simply want to create a user with actor. We expecting two parameters, name and email. They have some checks. And here, as I said, params, the single argument to the process function, it's a map with keys declared in the contract. So if we want to invoke this function, this operation, by default all the parameters are required. We invoke and get the error. Email and name are required. Bank version, it's obvious. And let's satisfy this contract. Email, name. And we received a successful result wrapped into OK tuple. We can add like additional parameter like meta. We expect it to be a map with some inner, with our expectation it should consist of key H with its own checks. It should be an integer, for example. With, I don't know, minimal requirement 18. We might have color, I don't know why. And let it be just, it will pass validation only if it's in a list, value in the list, blue and yellow, for example. We will add it here. And in user module, I don't want to change the database schema, so let's make it virtual. Okay, recompile. So now we expect meta. Let's satisfy it with age 17 and color blue. We got an error, and we have a hint that in meta we have an error within age key. Let's satisfy it, and we create a user of this new field. But currently we are mainly should be focused on the contract and unified output features. Let's get back to the actual subject of this talk. As I said, something happened with me when I participated ElixirConfEU last year. I was sitting on the third or fourth floor of the hall when Andrea starts to give his talk. There was a great talk, property-based testing is a mindset. Here is the QR code to the link with his slides. And this video available on YouTube. I encourage you to check it out if you haven't seen it yet. For those who are not familiar with Stream Data, here is the very, very short introduction. So Stream Data is a library that helps you to generate data with either basic predefined generators written or with custom generators written by you. Like here in Stream Data's example, we actually make email generator by invoking Stream Data string generator. Then we filter out blank names and use another Stream Data generator member of, which simply takes one of the domains, concatenate it with @, invoke the stream and get from the stream some amount of entries, in this case 2. Along with the ability to use predefined, as I said, generators and your own custom generators, Stream Data allows you to utilize them in property-based tests. Stream Data offers you a few markers for property-based testing. Here is the official Stream Data example. We use to generate binary generators. Here to generate data for this property-based test, which actually just checks whether string concatenated from 2 parts always starts with the left binary, left string. Very simple example, but good enough for this introduction. These are slides from Andrea Leopardi talk. At some point of his talk, Andrea mentioned a project for Google Summer of Code, sorry, a possible Stream Data feature, an ability to create generators by functions type specs. So the question was, what if Stream Data can read a functions type spec and prepare a generator that will generate data that then will satisfy this particular function. And at that moment I became like, what? Let's recall an operation declaration. There is something that's so close to type specs, but much easier to gather and inspect. It is an operation contract. You define your operation and already have some kind of type specs for this particular business process and for each particular parameter. So, well, actually it's type specs. And you have this specification for each operation, for each parameter. This is how, a year ago, an idea popped up in my mind. And the original question, what if we can generate a data by an operation contract? This is how ExopData was born. And the goal of this library is to help to write property-based tests by utilizing the power of Exop and their contracts and Stream Data. As ExopData awaits a contract as a major incoming attribute, by this contract, ExopData generates corresponding parameters data. The library generates a map where each key is our parameter name, and the value is the data generated and valid for the corresponding checks. And there is the goal has been set. One can use ExopData without Exop simply because I don't want to force anyone to use Exop. If you don't use it, okay, just make the contract with some rules and pass it to the Exop generate function, take some data. If you don't want to use it, okay. If you want to save your time, use it with Exop, because once you declare the operation, you already have this typespecs and this contract. You simply pass to the same function a module name, an atom, and ExopData already know in which place we should await and seek for the contract. It is possible to define very complex generators, but I encourage you not to do this. If you find yourself once declaring such contracts or checks for your parameter, please think about decomposition. Let's see how can we here is this simple example. We have NAB parameters, define it, and their checks. We pass it to ExopData generate function, take 20 and inspect. That's it. And we get a 20 generated maps with 2 keys parameters which satisfy those validations. And we already have adjusted and updated our create user operation. So we just pass this module name to generate function, and it generates parameters which we can just take and pass to the operation itself. Now let's talk about the most interesting part, property-based testing. As I mentioned before, StreamData provides a convenient way to write property-based tests to generate data. Let's see how ExopData might help you with this as well. Imagine we have an operation, multiply service. We just multiply two integers. We use a property macro from unit properties, the same macros as we use with the stream data, check all, and we just generate parameters with ExopData generate function, passing operation name. Then we, as I said, simply invoke an operation with this, with those parameters, take some result and starting to assert it. Simple as. For the significant part of operations, actually it's enough to use some syntactic sugar provided by ExopData to avoid boilerplate code, which we saw here. Here we do exactly with the same. Simply within this macro, we generate parameters, invoke this operation with them, and assert that this result, which we expect as the last line of the macro body, actually equals to the result returned by the operation. You know, and of course, if your test fails, you get the error, which actually all of us get used to. Sometimes you have to provide a certain value or your own generator, whatever, and you can pass those generators directly to ExopData. And here we define that A parameter should always be 1, and ExopData will generate A always equals to 1. Let's see it in action. So here we have some tests. I will use my snippet. So this operation should create a user, Here we pass a module name, we get the result of the invocation, run params, and assert that, actually we always know that if it's okay, we get a k tuple, and user creates it and match it to the result. And this test fails. Why? Because by default, when we define ecto module, ecto schema, string type here in user name actually mapped to Postgres varchar with maximum length of 255. And this operation fails with any string with length more than this 255. And I can say for myself, if I had been written unit test, highly likely I would provide it a name like, for this operation as a parameter, a name like test name or name or QWERTY, but most likely I'll never provide a name as a string with length more than 255. This is actually the great example of property-based testing goals. In order to fix this, we can do either, we can actually update our database schema and change the type, or we can go to the create user operation and say that, okay, name will be minimum 1 and maximum 255. And test again. Now it's green. If you want to see what actually ExopData generates for this, you can, it will be 300 parameters here. And this is an example for certain values. Let's say for some reason we want to get in our test this age, which actually within a meta parameter always be 20. We can define a map and say in meta I want to get an age 20. Actually, I want to use my sigil for this meta, and I want to use age 20. Nope. Ah, yes, we need to pass it here, of course. Generators, custom. And you see age is always 20. For example, you need to verify some behavior, some certain behavior. So now let's discover how all this actually works within the code. First of all, there is a simple behavior, ExopData generator, that states that every module, every generator module should confirm this behavior. It should take 2 maps and return always a StreamData generator. The first map is the actual parameter checks or validation described by you in a contract. The second map is inner options of ExopData library. This is an example of one implementation. So we have implemented for every supported by ExopData type data type, we have implemented those generators, for example, string. And we try to map our checks or validations options like is, in, minimum, maximum, etc. to stream data, string generator options, if it is possible. The main, actually, ExopData function is generate, as we saw. It takes a contract and it simply collects a map of stream data generators for all parameters declared by you in the contract. And it also applies some common generators and common validations for common options. What are they? For example, equals exactly in format, etc. Because if you know if you have a check with exact check and this, for example, H have check exact and value 20, you don't need, most probably, you don't need to generate additional generator for this, blah, blah, blah. You can just return stream data constant immediately. Somewhere in ExopData source code, later, depending on a parameter type, we seek for the corresponding generator module, as we see for the string before. We ensure that it exists. We compile it and apply this function from the behavior, because we'll know that it exists because it conforms the behavior. We apply some common filters and at the end we gathered, so we have collected a few stream data generators for each parameter. Now we start to combine them and collect into a stream data fixed map in order to get a map of parameters with their values. So in essence, this operations contract at the end becomes this stream data generator. No magic at all. Since ExopData library is relatively young, there are some limitations. We don't want to hide them. Instead, we talk about them. Like struct parameter is populated with a structure of random data because ExopData don't know, because structs, in struct you cannot specify the type of the field. So if you want to, if you have a structure with field name and age, and you don't, if you don't specify a special checks like inner, you will get a struct with name and age populated with like any value. And of course, data generating based on regex may be very slow. It depends on the regex itself. Complex generators like we saw before, very nested, may be slow, very slow. So think about the decomposition. If your operation, let's say, takes a huge map with nested fields and you specify in your contract that actually somewhere very deep in this map you need to check those two fields, maybe you need to pass those two fields and not to pass all this huge map to the operation. That actually means that this business logic requires those two fields, not this whole map. And of course, property tests by themselves for some operations may be slow. If your operation dealing with databases, for example, unit test invokes once when you invoke it. Unit test invokes, well, by default in stream data 100 times. So you will create 100 users. Obviously, it's much slower than one time. So those limitations actually mean and prove what has been said by much clever guys than me, before me, and will be said after me. Do not try to replace all unit tests with property-based tests. But sometimes it's really help, as we saw with type error with Postgres. I had no idea that I will get this error when I prepared this presentation. At the end of my talk, I'd like to share a roadmap or ideas in which I want to invest time next month, next half a year, for example. Operations chain support, when you declare operations, it's an Exop feature. You combine operations in some chain, so I want to add this support. Parameters coercion support, maybe consider proper as a possible data generator, or maybe combine them too, or allow you to choose which generator to use, stream data, proper, etc. Because all we need is just to create our generators for Exop types by confirming this behavior. And of course, constant improvements based on feedback. So we're all part of our great community. So let's continue do it better. Please inspire, learn, share, contribute. Additional credits to Alexander Fomin, another one maintainer of this library. And thank for your time. Thank you.
Thank you very much. That leaves us with 10 minutes for our questions. So, yeah.
Thank you for the presentation and the great work with this library. I'm more familiar with proper than StreamData, but I think both support shrinking.
Yes.
In order to take fully advantage, I believe ExopData also needs to support some kind of
the sweetest part,
or no?
the sweetest thing of ExopData is that actually, as we saw, at the end it is a stream data generator. Okay. So ExopData is another convenient way which actually helps you to create complex stream data generators. So yes, shrinking works because it's stream data functionality.
So even things like optional parameters, you will generate an example when it fails with the minimum amount of parameters that triggers the error. Because it was not clear for me from the example.
What if we?
But that's great.
What if we specify some optional?
Yeah, for instance.
Nice question. Let's see. Actually. Data generating example. Let's pass a contract there. Again. Yes, So, let's revise. Here we have a contract. I don't want to use operation now. 2 parameters. They are required by default. See? Every time we see A and B. Let's add another one. For example, C, let it be atom. And we state that it's not required. It's actually not required. Let's take a look. So sometimes we have C, sometimes we don't. And for example, if we generate data for map parameter, sometimes and specify within inner check some like age and colors, sometimes ExopData will add additional case, just in case of this is testing, property-based testing. What if you will receive additional keys?
Thanks for the talk. You have shown that ExopData can create valid users to test. And what if I would like to test if the name of the user is always valid, but the age is always invalid, to test the scenarios when process function returns the age validation failure?
Thank you. Good question. Well, actually, for the, as I said, for these cases, you can use certain values. You can provide it by custom generators. So I can make this age always be 17 and it fails. Okay, let's check it. Actually, it fails. Why? Because age must be greater than or equal to 18.
But based on the type specification in the code, can you generate values that are invalid?
No, it's not the goal. Why? Because if you need to specify some certain behavior within your test, then you pass predefined failed value which will fail this operation. But by default, you always get the valid data, valid values of your parameters. It's about, well, it's common sense, I guess, because you, in property-based testing, you generate like as much data as you can with corner cases, but I decided to make it all by default. They always pass the validation. It's much helpful, and you can use custom generators. And there is no way to specify in your operation contract, like, I don't know, it will be like failed validation or incorrect validation. So you specify validations, you specify rules, you define how it should be. So please use, at the moment, at least, custom generators. It will cover your needs.
Anyone else?
Hey, thanks for your speak. I'm wondering, can I use Exop and can I use it as some kind of type specs, but without validations? I don't want to validate function arguments,
yes,
but I want to use functionality as ExopData. So just to generate
so you can use
some values, but without
actually, if you don't want validation,
right?
But you want to specify these validations, but you don't want to use it.
No, you see, it's pretty good idea to have to use Exop. Yeah, it's really cool, but sometimes it's not ideal to validate inputs for functions. Sometimes you just need to trust that inputs are valid. So how can is it possible to not validate, just to have more detailed view of type specs?
So just like I have a module with your functions and define it contract just in order to document this code, to get this contract. Oh, the answer is currently not, but please, you can create an issue with your question and we will discuss it, and most probably we'll implement it.
Okay, thank you.
Thank you.
Well,
Thank you.
thanks for the talk.